software. In the Create Performance task, you will design and implement a program that might solve a problem, enable innovation, explore personal interests, or express creativity. Your submission must include the elements listed in the submission requirements section below. You are allowed to collaborate with a partner on the development of the program only. The written response and the video that you submit for this performance task must be completely individual, without any collaboration with your partner or anyone else. You do not have to use a partner, but you may use one partner to create the program. Once the program is created and you both have your own copy of the program in hand, then you each individually do your written responses and make a video of that program running. You can develop the code segments used in the written responses with your partner or on your own during the administration of the performance task. Please note that once this performance task has been assigned as an assessment for submission to College Board, you are expected to complete the task without assistance from anyone except your partner, and then only when developing the program code. You must follow the guidelines for completing the Create Performance task section below. So here are the general requirements. You will be provided a minimum, I'm going to do exactly as much as I can, 12 hours of class time to complete and submit the following. Your final program code, which could be created independently or collaboratively with the partner. Then you'll have to make a video that displays the running of your program and demonstrates functionality that you developed. If you have portions of the program that were not written by you or your partner, and you borrowed them from someone else, those are not the portions of the program that you should highlight in your video. You should make sure that your video shows functionality that you developed independently. Okay. Written responses, and of course, if you do borrow any code from anyone else, you give credit in the comments so that you don't get basically a 0 for plagiarism. Okay. Written responses to all the prompts in the performance task, you must write your responses independently. So there are going to be, and we'll go through the whole document and I'll show you my sample answers. There are like 4 questions you have to answer in. Each one has several parts. So it's kind of like 12 questions or so that you have to answer. I did the whole project in one weekend, and it was a long weekend, but I didn't sit there for 12 hours. I, of course, work more quickly because I have a lot of experience, but you should be able to do this in 12 hours time. So scoring guidelines and instructions for how to submit your performance task are available on AP Central at the AP Computer Science Principles exam page. You should check it out if you have any questions. Okay, we're going to skip the note because we are not in that environment. Okay, so here are the requirements. I already read through these with you once. Your program code should be submitted as a PDF file. So you can see from my Google Classroom post today, I have modeled that by, let's see, block 6, classroom, classwork, let me get there, create task, whoops, not see links, create task prep. Today's day 51. I have these 3 things attached. I have a video, I have a PDF of the code, and I attached a PDF of the written responses. That's not the format you're going to put your written responses in, but that's the best way for me to show you my written responses today. So my PDF of my code, I just literally went into code.org after I made my program, and I copied and pasted in text mode into a document, and then I saved it I printed it as a PDF, and I saved it and I put it here. So this is the kind of thing you'll have to submit, the whole program code in one document. So it should include comments, and you can see that mine does have comments at the top. It's got comments throughout to explain things. I used comments to put different sections and organize my code. Okay, so now include comments or acknowledgements for any part of the submitted program code that has been written by someone other than you and your collaborative partners. What this tells me is that you don't necessarily have to put a comment saying, I did this part and my partner did that part. You're allowed to collaborate with one classmate, not an uncle or a cousin who's in college and knows how to program. It can only be an APCSP classmate. That is the only acceptable partners, okay? You could work with a classmate from my block 7 or 8 class if you know somebody, you want to work with them, but that's up to you to collaborate then, and during class time, they may not be available to work with you. So I suggest if you want to choose a partner to collaborate with, it should be somebody that you've already established a good working relationship with. You know that they're not going to flake out and make you do all the work and then just ask you to give them the results. That would be crappy, okay? If you've worked with partners who've done that to you before, I highly recommend you don't work with them again, and you maybe would be better off just working by yourself, okay? So that's totally up to you. I'm not gonna force anyone to work with a partner, and I would try to facilitate it if you would like a partner and you want me to kind of put feelers out for someone who might wanna work with you, but it's really your decision, and this is something you're just gonna have to try to deal with, okay? So, you don't have to put comments to say my partner did that and I did this, only if you are researching and finding somehow code outside of your own knowledge that you bring into the program, then you want to give credit for where you found it. Put a comment with the URL of the website where you found the code. That's perfectly acceptable. You can borrow from other people, but you must give credit, okay? So in your program, you must include student developed program code that contains the following: input, instructions where it takes input from the user or a device or a data stream or a file. So it could be getting input from, get column from the database into your program, could be taking clicks from the user, text from a box, anything where you can get data input, okay? Even clicking on buttons to trigger events, that's considered input. You must have at least one list or collection type. We didn't really make our own variable types that they're talking about collection types, so list would be what you need for this, unless you know other languages and you want to work. You're allowed to work in a different language. You don't have to use code.org JavaScript. If you know something else and you want to develop a program in another language that I didn't teach you, you're perfectly allowed to do that as well. But you have to be able to satisfy the requirements of this project. So some people who've, hobby on the side, you're allowed to do that. There's no requirement it be the same environment that you were taught in class. Okay, so you must use at least one list or collection type, however, and it should have a collection of data that is stored and be used to manage program complexity and help fulfill the program's purpose. Some of you may have noticed when I graded your last project from Unit 5, the traversals project, your rubric score turned out you were missing, things just weren't working because, let's say, it didn't satisfy the purpose of the program. All right, you may have been attempting to traverse a list, but you chose bad loop control variables, you didn't go from the beginning to the end of the list, and so it didn't really satisfy the purpose of the program. You should look back at that if you have not seen your score for that Unit 5 make at the end. And if you have questions about that, I would recommend you see me on office hours so we could talk it through and I could teach you more to learn from that experience. Okay, so anyway, you must use a list. You must have at least one procedure. That means function in JavaScript. A function that contributes to the program's intended purpose, where you have defined the function's name, the return type, if necessary, and one or more parameters. So it must have a name of a function that you chose, and it must have at least one parameter It can have a return type, and if it has a return type, great, but it doesn't have to, because that's may not be necessary. Okay, notice that event handlers or main methods, we don't have main method in JavaScript, but event handlers do not count as your student-defined procedure. You need to define a function elsewhere in the program, and then in an event handler, you can call that function, but you've got to define the function yourself, not just count on an event handler as being a function. It's not really satisfied, doesn't satisfy this criteria. So another thing your program must have is an algorithm that includes sequencing, which means things being in order. Selection means if, else, if, that kind of conditional statement where you choose this or that. And iteration means repeating, repetitive, something like a loop, okay? That's in the body of the selected procedure. So the procedure that you want to highlight and that you're going to be showing off in your project is going to have this algorithm inside the function. And then, of course, you're somewhere else in your program, you need to make calls to that function so that it runs, okay? And your program should have instructions that provide output to the user. Somehow the user sees something on the screen or hears something, or they receive information or whatever. It's got to have output. So input, processing, outputs, basic programming, okay? Secondly, you must create a video. One video that demonstrates the running of your program as described below. You cannot collaborate on the video. Every person must have the program working on their own workspace and be able to take video of it. I will give you recommendations for software that I think is good. Screencastify is one that the Google Chrome extension that the school provides. You could use that. I also personally prefer Screencast-O-Matic, which is a free software. It only has to be a 1-minute video. So free versions of these screen recording softwares is all you need. You don't need something that's, you have to pay for. But every person will have to take video of their program running. Collaboration is not allowed during that portion of the project. Your video must demonstrate your program running, including showing input going into the program, show at least one aspect of the functionality of your program, and show output being produced by the program. Your video may not contain any distinguishing information about yourself. You should not put yourself in the video or your voice. They want this to be anonymous when they grade it. And the reason being, I've been told, is that they want to be sensitive and make sure that the graders do not have any implicit bias when they look at programs. So if they cannot see your face or hear your voice or see your name, they're not going to be like, whatever personal bias they may have, should not be able to affect their grading of your project. Okay, so don't include your name, your image, or your voice. You can put captions if you want to explain stuff as the video is running, and I showed that in my video, okay? Your video will have to be one of these formats, MP4, MWave, AVI, or MOV format. Basically, any of these screen capture softwares, you can choose the format, and it must be no more than 1 minute in length. That means even if it's 1 minute and 1 second, it won't upload. So I recommend that you think of no more than 1 minute as being 59 seconds or less, okay? Even 60 seconds is probably too much. It must be less than 1 minute, okay? And the file size of that video must be 30 megabytes or less. And if you, once you have your screen software, recording it, you can save it, check out the file size. It should be okay for a minute video, just as is. But if you have any trouble with that, that's one kind of thing that I can help you with. I can help you with technical details like making sure the file size is correct, but I can't help you with the content or the creative part of making your program. Okay, So now we get to the written responses. By the way, let me show you my video. So I gave you the PDF of the code. Here's the video of it running. Okay, that's my whole video. Okay, so my written responses. Here are the written responses, and I have my answers built in so that you can see that they satisfy the requirements. There are 3A to 3D. Here's all the written responses. It's pages, but let's see. Your response to all prompts combined must not exceed 750 words. Let's just say I don't think they're actually going to count words, but you don't want to try to make stuff sound better just by pontificating, okay? Brevity and clarity is better than wordiness for these answers, okay? Distilling down and making sure you answer the question being asked fully without going on and on with extra words, that's what they want to see, okay? So after you write a response, if you can eliminate any words that don't really add to the meaning of what you're saying, you want to do that as long as it's still grammatically correct. Okay, so provide a written response for 3A that does all of the following things. And remember, you're going to be answering these questions yourself, not you and your partner together, not giving the same answers. At this point, the program is written. You individually must do this on your own. First, describe the overall purpose of the program. So think back to the beginning of the description. The purposes of the program could be, let's see, it could be solving a problem, it could be enabling innovation, it could be exploring a personal interest, it could be expressing creativity, okay? So that's like a general purpose type of thing. So I wrote the purpose of my program is to model a small working digital piano keyboard with 1 octave for the user to experiment with musical melodies composed of series of musical notes. The user can press the keys, hear each note as it plays, record basic melodies, play back the recorded melody at 3 different paces, normal, slow, or fast, and also play back the melody in reverse. I kind of left out that they could, which is a weird little quirk, I just kind of added it for fun, type in a melody and it would take each letter, convert it to a number, and then match up that number with a note and just randomly create a melody from words, which was weird, but what the heck, why not? So also something weird about my little piano, the black key notes don't work. I did not implement those. The sounds are not great. I really literally just recorded from another piano app. I recorded sounds to go with each note, and then you can hear a little bit of static in the background. I didn't do research looking for the best sound files to go with it. There's a lot wrong with it, but it satisfies the requirements, if you ask me, because as a person is clicking on the buttons, that's input going in, and the notes when you're recording are being added to a list so that it could be played back by just going through the list and making the sound come out again. So I have a list, I have traversal, I have, you'll see, conditionals and all that. So describe what functionality of the program is demonstrated in the video. Now we just watched the video together, so all I'm doing is describing what's in the video. The video shows what happens when the user plays the piano keys, uses the record button, plays back the recording at normal speed and reverse. Then the user types a phrase in the text box and clicks melodify it. The program converts each letter of the phrase to a note of a melody and plays it. Then the user plays the new melody fast also. So I'm literally just like narrating what happens in the video. That's your 3A part 2. Then part 3, describe the input and output of the program, demonstrating the video. The program takes input in the form of user clicks on the piano key buttons. I probably should also have said, or typing into the text box, but I kind of left that out. The output is in the form of sounds of the corresponding notes in the same sequence as entered or in the reverse order. And the output is always at a steady pace. There's no rhythm in this. So that's another weird thing about this little piano app. It makes everything just like a metronome, steady pace, no long notes, short notes. So if you're a music person, you're gonna be like, this is silly. I would never want to use this piano. But you can choose what pace, normal, slow, or fast. The output also includes text display of the sequence of notes in the text box. So just the note that you have on the key. Okay, so there's my answer to 3A. 3B, capture and paste 2 program code segments that you developed during the administration of this task that contain a list or other collection type being used to manage complexity in your program. The first program code segment must show how data have been stored in the list. Now, please note this little red note over here. In order to show you my answers, I just took the written response document and I superimposed my answers on it. This is not the same format that you will be handing in your answers. You're not going to take this document and type on it and then submit it as a document. You are going to go into the College Board digital portfolio when it's time, and you're going to find there a place where it's like a form filler, like a wizard, where you have to open it up and it will give you a box to type in and you'll put your answers in there. So I'm pretty sure that the space will expand to fit your answer, and or maybe make a scroll bar or something. I was just kind of trying to fit as much as I could on this little document, and you won't have to do that, okay? So you probably won't be taking necessarily screenshots like this. You might be just selecting code and copying and pasting the text code itself so that it's more readable. I just couldn't fit that on this format. So I would say I would not be turning it in looking like this, because unless maybe I make it bigger, like this is a little bit too fuzzy, this image of this code. I mean, I can read it, but it's small and it's a little fuzzy. It's not good quality answer, like in terms of visibility. So I would be copying and pasting the text into the box. And in fact, when you go to answer your written responses after you've created your program, you probably want to like open a Google Doc and type out your answers in there to kind of do a draft and have like a place where you keep them. Because once you get into the digital portfolio and you want to like put your answers in, if you don't do it all in one sitting, I'm afraid of whether the answers will get saved or not, because this is a new system this year. So I would recommend having a draft in a document, and then when it's time to enter them into the form, you just copy and paste what you've written from your document into their like boxes, okay? So anyway, that's the kind of thing, as we go and we get closer to the end of this project, I will probably do more of like reminding you and instructing you and demonstrating stuff. I can help you with the technical aspects of submitting your project, but I can't help you creatively or with debugging or with ideas for how to write code. Okay, so I have a code segment that shows how data has been stored in a list. First, I show the declaration of the lists as global variables, and then I show this section of code, append item. That's how the data is getting into the list. When the program calls a function called add note and it sends along a parameter called note, that note gets added to the song notes list, which is just a list of letters. And then it actually gets the .mp3 appended to it, and that gets put into a URL list so that it can play those sounds. Okay. The second program code segment must show the data in the same list being used, such as creating new data or accessing multiple elements in the list, or as part of fulfilling the program's purpose. I did not create new data from the input data, but I did access multiple elements after it's in the list. Right here in this segment, what this does is play back the whole list of notes, one at a time. And it does it in two different ways, either forward or backwards. So this one function shows either way. So you have like song URLs dot length. It's traversing through the list of song URLs, and it's updating I each time. And then if we're not at the end of the list, we play that URL. So it's a loop. It's a little not like the same loops that I've shown you before, because I wanted it to be timed. If I did it with just a for loop or a while loop, I tried that at first, and it would just be so fast that you just hear all the notes at one time. So I found a new kind of loop called a timed loop that would meter it out and only play the notes one at a time and put a little wait time in between so that you could hear them individually. But that's a loop, and it's going through all the elements. Okay, so provide a written response that does all three of the following. First, you have to identify the name of the list being used. The names of my lists were song notes and song URLs. You really only have to mention one list, but since I only had two, I just threw both of them in there. Those are the names of my lists. Then describe what the data contained in the list represents. I kind of described each one. Each piece of string data in the song notes list represents a musical note corresponding to a note that was played or will be played in a melody. Each piece of string data in the URL list represents the URL of the sound file that will be played for a given note. And then explain how the selected list manages complexity. As you can see, this is going to be kind of a lot of people saying similar things, but you got to write it in your own words, because basically a list manages complexity. It keeps the program from being too complex by storing things in one place, right? Instead of me saying, okay, I'm going to let a person play notes on the piano, but I'm going to store each note they play in a separate variable, then I'd have to declare all those variables up front. And let's, like, note 1, note 2, note 3, note 4. And that would just get cumbersome. And I would have to probably decide in advance how many of those I'm going to make and keep it fixed at that number for the whole program. So it would not be as flexible. So a list, which you can append items to, and it grows and shrinks as needed, helps to manage the complexity of this program. Okay, so you can read my answer there. Then 3C. Here's where they focus on the fact that I had to develop a procedure or a function, all right? You have to include a program code segment that is student developed procedure. That means a function. So you can see in this, I have a function called play recording. And it shows, it has two parameters, speed and a Boolean called is regular. Basically that distinguishes, are we playing this forward or backwards? If it's regular, we play it forwards. If is regular is false, we play it backwards. So it contains and uses one or more parameters. I have two parameters, so I satisfy that checkbox. And it implements an algorithm that includes sequencing, selection, and iteration. Sequencing, I've got things in order in a list, and I've got a sequence of steps to take. That's what sequencing means, step-by-step procedure. Selection is if, else. There it is. If is regular, do it this way, forward. Else, backwards. Okay. And iteration is looping. So my timed loop takes care of that. I have actually a timed loop for each of those. It's just whether it goes forwards or backwards through the list. So I've got all the parts of this algorithm. Then it says the second program code segment must show where your student developed procedure is being called in your program. So earlier on in my code, I have lines 62 and 65 here. When a person clicks on a button, like a fast play button, I call the play recording function and I send in a particular speed. If they click fast play button, 250 milliseconds means it's just a shorter gap between the notes being played, so that's a fast. And true means forward. It's playing normal. Then here's another call to that same function, play recording, but this time 500 is kind of standard speed, and false means we're doing it in reverse because the person clicked on the reverse button. Okay, so there I have two places where it's being called. Then part 3 here, describe in general what the procedure does and how it contributes to the overall functionality of the program. So I'm not giving as many details in this answer because it's supposed to describe in general. I'm just saying it plays sound files that correspond to a sequence of notes in a list. This algorithm uses the isRegular parameter to determine whether to play forward or reverse. It uses the speed parameter to determine how many milliseconds to hold the note. This is the main algorithm for playing back melodies, either recorded from clicks on the keys or typed in as text and converted into a melody. Then the last part, explain in detail, in detailed steps, how the algorithm implemented in the identified procedure works. Your explanation must be detailed enough for someone else to recreate it. So here's where I actually describe what's happening in the code. First, the algorithm checks the isRegular parameter with an if statement to determine the type of loop control setup. If isRegular is true, then the loop control will start at 0 and go up, increase to the highest index of the list. Otherwise, else, if isRegular is false, the index will access the last element first and decrease down to 0. In both cases, a timed loop is created using the speed parameter to set the millisecond timeout, and the body of the loop plays the current sound file, updates the screen, updates the loop control variable, and checks whether we should continue the loop. So that's details about, I'm just kind of in words describing what's happening in my algorithm. Okay. Last written response question. Provide a written response that does all following. 3D. First, describe 2 calls to the procedure identified in written response 3C. So here is 3C, the 2 calls. Here's my 2 calls. Play recording from the fast button and play recording from the reverse button. Each call must pass a different argument that causes a different segment of code to execute. This call to play recording is used when the user clicks the fast play button. It sends 250 as the speed argument value. So here's my call, and then I'm describing how the 250 means that it's going to play fast, and true means that it's going to play in original sequence, not reverse. My second call would be play recording 500 false. This is used when they click the reverse button. It sends 500, which means it's 500 milliseconds average speed, and it sends false so that the isRegular argument means the melody will play in reverse order. So I'm showing that based on the true or false parameter, it is going to hit the if part of the algorithm or the else part. It's going to execute 2 different portions of code depending on that parameter. Your function needs to have the same kind of setup where your parameter is being used to make a decision. Whatever function, you may have more than one function in your program, probably, but you have to have at least one function where this is the case. You could call it different ways, sending in different parameters, and they make an effect on which portions of code are executed. Otherwise, you're not going to have an answer to this question. Okay. Part 2, describe what condition is being tested by each call to the procedure. So my first call is testing the case where is regular is true, which tests the first half of the if else conditional. So it tests, will it run the loop in forward order? The second call, that would be this play recording 500 false, tests the case where is regular is false. So it causes the else portion of the condition to execute. It tests out whether the program can really run the song in reverse. Okay, so when I make those calls, those two different ways, I'm exercising or testing different parts of the algorithm. Okay, and finally, identify the result of each call. The result of the first call is that the notes play in original sequence and they are played for the number of milliseconds indicated by the speed argument. The results of the second call is that they are played in reverse order of how they're stored in the list and for the number of milliseconds indicated by the speed argument. So I could say more specifically, you know, the first call would be 500 milliseconds or 250, the second would be 500 milliseconds each, to be more specific, but the difference there is really whether they play forward or backwards. So a lot of these answers in my case ended up being a little bit repetitive, but I'm answering the question that is asked. Okay, so there's my sample. Now, in looking at my sample, we have read through to the end of the create task requirement document. So that's everything that they officially give you to say, now you know what you have to do for your project. Okay. Now it's 9:30. This is 8:45 to 9:45. Okay. There's 15 minutes left of class. And I would like to start this homework with you. Okay. The Desmos activity. Oh, by the way, before we do that, do you guys have any questions from anything that came up while I was going through that requirements? You could put it in the chat or you could just ask. Look back through, you know, read back over things. If anything at all doesn't make sense to you or you need clarification about what's allowed and what's not allowed. I will say one more thing. Starting next week, you're going to be working on this create task for 12 class hours, which is going to take up a large majority of Q3 classes. So even though this create task is something that is both required by the College Board for you to submit, and also it's part of my class time, I will not be allowed to give you feedback on the project until you have officially submitted it to the College Board digital portfolio and you've submitted it final, where you can't take it back. Okay, I'm not allowed to give you feedback on it. I'm not allowed to give you a grade that says I think you got this score on it until it's submitted finally. Okay, so the grade that I give you for this project overall, which is usually about 100 points, is not going to be in third quarter. It's going to be in fourth quarter because I have to wait and make sure that everybody's got theirs submitted finally before I put it into my grade book. But every day that you work on this project, there will be a short Google form attached to a Google Classroom post that you'll have to fill out. It'll have leading questions, questions that remind you of things, and you have to answer them, and that will make your brain focus on certain portions of this project. It'll be my way of kind of like giving you something to show that you participated for the day, and those are the grades that are going to count in Q3. for this 12 blocks of class time. Just a little Google form that you'll have to fill out each day of class. Kind of like attendance, but it'll have some questions in it, just a few, nothing big. I don't want it to take a lot of your time because I need to give you that hour to work. So it might be that the hour of class time, I just come on Zoom, take attendance, get to work. And then homework is fill out the form. Okay. Homework might also include watch a little video, like a 5-minute video that I find as a resource that would be good to remind you of all the requirements, and maybe like tutorials on how to take screen capture videos or how to make sure your file is the right size. I may send out little videos for homework like that, but the class time, the 1 hour, is going to be dedicated to you working on the project. I don't want to take up your time during class because I have to give you 12 hours. So any questions before we look at this next sample? Okay. All right. Did Stephanie make it in?
Yeah.
There you are. Okay, sorry about that. I must have missed that you were waiting. I will send you a recording of anything you missed here, okay?
Okay, thank you.
All right. All right, so we're going to take a look together at the Desmos activity. Click on the Desmos activity. We have a few minutes to get that started together. It says enter your name to begin. Do you guys see this screen? Does it let you in? Go. Okay, so it says the following slides will look at the scoring guidelines that the College Board has published so that you'll know how your project will be scored, and you'll be using a sample to evaluate things. So the scoring guideline has 5 pages to review. Okay, looks like the last page is just terminology in case you are fuzzy on any of the vocabulary in the scoring guideline. But this is basically like a rubric, it's the project will be scored by the College Board according to these 6 rows that they're going to be giving you either 1 point or no points for that criteria. So your score on the create task will be a score from 0 to 6 from the College Board. That's not how I'm going to score it when I get to quarter 4 and I look at the content of your project. My project, like, I need more than 6 points for this to count in my grade book. And I'm not going to do a 6-point row thing and then multiply by 10 or something. I feel like that would be disastrous for some people, because if you don't get the criteria, you're going to lose like 10 points at a time. So what I will do is I will take the guidelines that we just read over and I will break it out into a checklist. And basically I'm going to go through your project and I'm just going to check off that you met all the criteria, and every criteria that you meet will be more granular, like 1 or 2 points. But there's a lot of criteria to meet. So if you get this and you don't get that, you're going to end up with probably a better score from me than the College Board. That could be the case. But so my score could be different than the College Board score because it's not even going to be the same strategy. But they will be looking for these criteria. First, row 1, program, purpose, and function. Your video must demonstrate the running of the program, including input, program functionality, and output. And your written response must describe the overall purpose of the program, describe what functionality of the program is demonstrated in the video, and describe the input and output of the program demonstrated in the video. Would you say that I would get the point for this row of my sample task? Did I do all of that? The only thing I'm slightly worried about now looking at this is whether I described the purpose of the program well enough. Like I said what it does, but what's the purpose of having this little piano app? Is it to learn piano? Is it to experiment with melodies? Is it to just have fun? That would be more like the purpose. And I don't know that I did a great job saying that in that answer. So purpose of the program should be a real overall general statement as to why would someone use this app? Okay. So I'm a little nervous about that. But anyway, consider only, thankfully, I don't have to turn in my sample, you know, only you guys have to do that. Consider only the video and written, okay, these are notes to the graders, the people who sit down in the summertime and look at your project and give you a grade from the College Board. They would only consider the video and written response 3A when trying to score this. They would not award a point if the video does not show a demonstration of the program running. So you can't just take screenshots or storyboards. You have to have a running video showing it working. Okay. You don't have to hand in a link to your code. The graders are not going to be able to run your program themselves and find out that there's a little part of it that doesn't work. Like maybe they could spot that in the code, but they're not going to be exercising all the code themselves. They're just going by what you show in the video. Okay. So row 2, data abstraction. You must include 2 program segments, one that shows how data has been stored in a list, one that shows the data in this same list is being used as part of fulfilling the program's purpose. You must identify the name of the variable representing the list and describe what the data contained in this list represents in the program. So you can look at the scoring criteria, how they would not reward a point if the use of the list is trivial and doesn't actually assist in fulfilling the program's purpose. If you create a list, but then like don't use it or use it in such a way that it doesn't really contribute to the purpose of the program, you may lose the point even if you have a list. Row 3, managing complexity. The written response is what they're scoring you here on. Does it include a program segment that shows a list being used to manage complexity in the program? And have you explained how the named selected list manages complexity in the program by explaining why the program code could not be written without it, or how it would be written differently without using the list? Okay, lots of decision rules here that you can read over, whether it should earn a point or not, based on all these bullets here. Row 4, procedural abstraction. This is all about you making your function. You must show one student-developed function with at least one parameter that has an effect on the functionality of the function. One code segment must show where that function is being called from. So a call to the function. Then describe what the identified procedure does and how it contributes to the overall functionality of the program. Again, more things to consider when issuing a point. Row 5, all about your algorithm. Does that function include an algorithm that has sequencing, step-by-step instructions, selection, if then, if else type of thing, iteration, loop, has to have all of that in your function. And probably the loop would be iterating through the list. That would be the most obvious way to include all of this stuff. And the if conditional would be like, as it examines a particular item in the list, if this is true, then do something else, do something else. That would be one way to incorporate all of that. And explain in detailed steps how the identified algorithm works in enough detail that someone else could recreate it. Okay, and row 6, the written response describes 2 calls to the selected procedure, and it describes the condition being tested by each call and identifies the result of each call. So this is just breaking out the different written responses. Notice that there's nothing in the scoring guidelines that is judging the quality of your idea for this project. Like, they're not going to judge, like, do we like this app? Okay, if it satisfies these criteria and you've written it up to satisfy these criteria, then any idea, as long as it's school appropriate, should be fine. And it's got to have all these programming features like a function and list and, you know, iteration and stuff like that. But they're not judging whether your app was a good idea or not. Okay, so that should kind of settle any fears that you're not in a contest to try to win like best app, you know, development by a APCSP student. Although I would like to see you do the best you can and come up with something cool. But you know, anything you come up with, as long as it satisfies these criteria, is fine. So that's all we have time for today. You continue through this Desmos activity. Let's see how to go to the next part of it. Okay, so you got to go back to that, go to next. Oh, we just kind of read through these things, but now you have to just put some answers in to show that you understand these scoring criteria. So there are 15 slides. That's your homework. Next time, we're going to look at more samples together. And any questions you have, we will answer. That's it for today. Sorry I had to do so much talking. It's just one of those days, but I'll be quiet for 12 days after this talking is done, and you'll be working, which is fun. So hope you have a good night, and I will see you on Friday.